Hello students, in previous class we have started or we had picked one language that is WWR, and we want to know that can we design push-down automata for this language. The answer is yes, we can design the push-down automata, but we need to make certain additional things or we need to deploy one additional power, that is non-determinism, in our push-down automata. So whatever we have done so far, that is DPDA, deterministic push-down automata. Now we will pick the designing of non-deterministic push-down automata. Now why we want non-deterministic push-down automata for WWR? Why we cannot make DPDA? The reason is that in WWR what we have, we do not know when we will get the midpoint. So to identify the midpoint each and every time, what we need to do, we need to make a guess, and for that guessing we require non-determinism. In deterministic you cannot guess. So that is the major point, that why we cannot design deterministic push-down automata for this thing. Now here please notice one more thing, that as we have done in finite automata, we say that for every deterministic finite automata we can have non-deterministic finite automata, or every non-deterministic finite automata can be converted into deterministic finite automata. This is not true in terms of PDA. It's not necessary that for every non-deterministic push-down automata you can convert it into deterministic deterministic push-down automata. So power of NPDA is not equal to power of DPDA. NPDA have more power than DPDA. So be careful, both are not equal, or you cannot convert every NPDA into DPDA. So let's check that how to write rules for non-deterministic push-down automata. Now the thing is, here rules will be written just like deterministic push-down automata, but we need to take care of few things. For example, in this particular WWR, what we need to do, we need to somehow identify that where will be my midpoint. Once I have identified the midpoint, everything will go smooth. So let's try to write this thing. Now, first rule is Q0, AZ0. Definitely, it can get started with A or it can get started with B. So for both, I have written AZ0, BZ0. Now the thing is, what will happen? I have A, suppose. Now after this A, the next thing which will comes. Now there is a possibility that it have only double A. So it means that after A I have one midpoint, and next thing we want to make deletion. So here what I want, I need to make two different rules for the same thing. That is, if I'll get A and top of the stack is A, then there is a possibility that I am going to insert element into my stack, or there is a possibility that I can delete it. Hence, now there is a choice. Because I don't know the future, what I can do, I can give the choice that pick any one and proceed, and if anything gets wrong, then repeat with the next one, which is actually non-determinism, that you have multiple paths and you should have at least one path through which you can reach into your final destination. So here I have used the same thing. Similarly, once I have double B, what I'll do, either I'll insert or I'll delete. other thing, if I have BA and AB, I already know that these things are not palindrome. So before I'll start a deletion, I can straight away insert it. And that is the main reason, as you can say, for deletion I have used the state Q1, and for insertion everything is in Q0. And once even single deletion get performed, it means that I have goes beyond to my midpoint, and hence the only thing which is possible, that is deletion. So how I'll do the deletion? After that, whatever I am getting, and if pointer is pointing to top pointer is pointing to A, I am going to delete. Similarly for B, and if everything gets smooth and nothing get wrong, I'll move into state where my input get over and my stack get empty, and I'll say that I reached into final state without making any change here. So I hope that you got that how to proceed with respect to non-deterministic push down automata. We need to make choice, and we need to be very careful that where I should give choice, and once I have given choice, be careful with respect to your state movement, that states should get changed for different operations. So here is one tip also, that when to make change into my state. So although there is no perfect answer of it, but yes, there is a tip that when there is any change in operation, suppose you are making moving from insertion to deletion, deletion to no change, no change to insertion or deletion, then there is a maximum possibility of state variation or change in state. Otherwise, it only depends upon practice. The more you do practice, more you will identify that when to make change into state. I have already showcased you that state have utmost importance with respect to designing and acceptance and rejectance of any given string for any given language. So that we have done with respect to PDA. We had picked examples of designing of deterministic push-down automata, which I have straight away said PDA, and we had picked that there are certain problems for which deterministic push-down automata cannot be designed directly, rather cannot be designed. For those things, we can design non-deterministic push-down automata, as we have seen WWR, for which we need to design the non-deterministic push-down automata, where we need to give options for movement. So that is overall with respect to push-down automata designing. Now in next class, we will move further. Might be designing of push-down automata from any given context-free grammar, because right now we have only picked straight away language, and from that language we have designed the push-down automata. Now in next class we will pick that how to design push-down automata when grammars are given.